Let's take another look at the middle and lowest generation of the lepton hierarchy. As noted before, we can see that the only combinatorial value, which was -3, will be given only by the generic components of the compositions. And so, in this case again, we have a generic electron and we have a boson 0 that has no combinatorial value and does not involve a combination of a flavored and non-flavored pair. And so this muon is equivalent to a generic electron. Now here we have again generic composition of the electron, and we have a boson plus, which again there's no flavor or pram mixing, and so the combinatorial value is 0, and so it will create electromagnetic inversion and therefore change the mass, but make no contribution as a mass factor. And so then we have again the 125/100,000ths of an electron unit of the muon neutrino. Now in here we have, of course, not only the generic component, but we also have a scalar boson component providing a positive combinatorial value of 2. So we have a negative times a positive, so it will provide a decreasing mass factor. And so we have the 200 electronic units on the muon, and then we have this boson plus, and in this case, after converting the muon to a muon neutrino, provides a decreasing mass factor and gives us the electron neutrino mass. So this is a composition of an electron neutrino. One thing to observe about this composition is that the generic rishons cancel out, and this V prime then can be thought of as combining with this generic electron, giving you a composition that involves expression elements that arise from a single fundamental, and that's why they have the same single colored cone. In this case, single color cones are purple, and so this is considered to be a unity in that it doesn't include any of the expressions from another fundamental. And that unity gives us our least mass value. Now, here we have again the muon neutrino. And the muon neutrino has a combinatorial value of -3 interacting with the boson 0. Has a combinatorial value of 2, so we have minus times a positive, which gives us negative, so we would have a decreasing mass factor on the boson 0. In this case, this configuration also gives us the mass of the electron neutrino. But we have added to this composition two flavored particles which are have opposite flavor, so therefore are contributing no flavor, and therefore keep the composition in the electron neutrino lowest hierarchy, and therefore inverts the electron neutrino to an electron. And so, in this way, you can have various compositions that might represent the lepton systems or particles. But this particular schema, based on attributing values to the prime, flavored, and Rishon elements, and generic Rishon elements, depending on their configuration, to provide factors for the generic, will always give you masses that are consistent with the standard model and in association with particle configurations that reflect the identities of the particles in the standard model. Of course, in this case, we're talking about muons and muon neutrinos, and electrons and electron neutrinos.